Dimensional analysis, we're going to do a quick rundown that will hopefully refresh memory and get that all of those gears turning. And if you're someone, so if you've had chemistry, you're probably pretty familiar with this. If you haven't, it might take you a little while longer to get going, but that's okay. We'll practice and you're free to ask questions. This, though, is probably the most useful tool you will take out of maybe math or science, maybe across the board even, because it can be applied to so many different situations if you get good at it. Essentially what dimensional analysis is a way to convert numbers from one unit to another unit without changing their value. But we can broaden that unit to mean a lot of different things. We used at one point, just as a kind of say ballpark, how much carbon dioxide is released by vehicles. And we started out with the fact that a gallon of gasoline produces 16 pounds of carbon dioxide and went from there. So you can expand it quite a bit. Now that was a fairly long problem. It was just a discussion that we were having one day in downtime. But that highlights how impressive or how important this can be. But let's just go back and review some fraction rules because they are applied here really, really often. So let's say that we have 1/2 time, and yes, we can use fractions for this particular thing. 1/2 by 1/3, how do we determine what that's equal to? What's that? Just multiply across. This is 1 times 1 is 1. 2 times 3 is 6. Easy peasy. What if we get something like 2/3 times, easiest way would be 3/7. How do we make that simpler for ourselves?
You would take out like that common factor, like cross out the denominator 3.
If we've got a 3 on the top and the bottom, we can easily just cross that out. Now, there's still a 1 in each place, so it doesn't turn to 0. But we cross those out, multiply across, and now we have 2 on the top, 7 on the bottom. What if we bring in some algebra? What then? Oh, we can cross out just a part of it because they're together. So we would take out the x and the x. Those get a factor of 1, so it would be 2 times 1 instead of 2 times x, or 7 times 1 instead of 7 times x. Let's do that a little differently. But the x's go away. So we'd have 2 times 4 is 8, over 3 times 7 is 21. What if instead of this we said something like 2 centimeters over 3 times 4 meters over 7 centimeters? Just as a crazy example that's not really worth real world. Essentially. Yeah, essentially. That's where you use it most in chemistry. We can do the same thing here with the units. Right? We treat them very much like we treated the x. Well, we've got a centimeter here and a centimeter there, so those cancel. We leave anything else, so we have 2 times 4 meters, 4m, so that's 8 meters, over 3 times 7, 21, and then if this were an actual conversion, then we would convert that with appropriate significant digits into a decimal form. Now, we aren't going to see something like this very often in here. Mm-hmm.
So if you were to have to convert that, what would you convert it to? Like
Oh, so 8, so somebody tell me, what is 8 divided by 21? Well, you've got calculators.
3.8?
No.
I mean, 0.38.
Okay, that'll work. 0.38 and probably goes on to be meters. How many significant digits do we get based on the problem? 1.
4.
So it'd be,
So you just divide by.
yeah, top by the bottom. Yep. Okay, now, so that's sort of the general stuff. Let's talk about how we would use this to convert things. And we're going to do simple conversions just in the metric system to begin with, because we know what those steps are. Let's say that we have 73 centimeters that we want to convert into, let's make it meters. Simple, just to practice. The steps that we're going to follow here are to take whatever we're beginning with, and this is maybe the hardest part to identify in some problems. What units are we beginning in, or what do we know at the beginning, or what do we define as our reference point? And we're going to put that over 1 to remind ourselves that it's a fraction. And I don't care if you do one big line and divide it up. That's like the picket fence thing. That's fine too. We can multiply this by fractions, but the important thing is we don't want to change the value of this. We just want to change the units that it's reported in. So if we don't want to change the value of this, whatever fraction we multiply it by has to still equal 1. We're going to write that fraction that equals 1 in lots of strange ways, though. If a fraction equals 1, what can you tell me about the top and the bottom? They're the same. They have to be the same. But there are lots of ways, as we're converting, things are equated to one another. For example, if we were to set something up that is a fraction of 1 but relates both meters and centimeters, we would say, well, I know that there are 100 centimeters in 1 meter, so those two things are equal. When we're setting this up, what we start with here gives us a big clue about how we want the next fraction to look. We don't want centimeters in our answer. We want to get to meters. So I want to cross centimeters out. And I know from up above that if I put it on the bottom, I'm going to be able to cross those units out. So just looking at if I set it up here, I know what I want in the bottom of the next fraction. And then I go up, what can I convert centimeters into? So how many centimeters equal how many something else that's going to be useful for me? And I've already defined that. I know this is a 1 step. I know that 100 centimeters is equal to 1 meter. This fraction is equal to 1 because it's the same value on the top as on the bottom. So I'm not changing my value, I'm changing my units. I can cross out those units, and once I get to the eventual units that I want, I stop. If I had to keep going, which we'll see, I'll just keep adding fractions. I multiply those out. So 73 times 1 meter is 73 meters. On the bottom is 1 times 100, it's 100. So I have to divide this. There are no units left on the bottom. I get 0.73 meters. How many sig figs does that have? Why?
Because the original problem was just converting 73 centimeters to meters, therefore you only have to do some.
Okay, so 2 from up here.
Mm-hmm.
How many does the number 100 have?
1.
How many?
1. But that wasn't part of the problem.
And it's the defined thing because it's defined and we know it's exact.
Right. This is exact. When you're converting within units, it's defined that 1 meter is exactly 100 centimeters. So when you've got conversions like this, you don't have to worry about them in significant digits. So we go back to the original problem, which was 73. Let's try something that's a little bit different, though, from that. Let's say that we say 73 centimeters into feet. I don't remember how many centimeters go into a foot exactly, but I do remember that there are 2.54 centimeters in 1 inch. And of course that there's 12 inches is 1 foot.
30.48.
We're getting there. I want you to write them out. These are easy. We're practicing the method using it. Yeah, these are easy enough that you could probably just do without. We're going to start the same way, whatever we're given, over 1. I know that my next fraction should have centimeters in the bottom, so I can cancel those. And so I look up, okay, I know how to get it, maybe not into feet, but into inches at least. And I know that this becomes my fraction. The number 2.54 goes with centimeters. The number 1 goes with inches. That would allow me to cancel centimeters and centimeters. Now, I don't want to stay in inches, I want to get to feet eventually, so that tells me I want inches in the bottom so that I can cancel these. And I know that there are 12 inches in 1 foot. So I cancel inches and inches, and all I'm left with is feet, so now that's the units that I wanted to convert into. So we'd have 73 on top, feet. Multiply out the bottom, 30.48. Which Zach has already told us is how much when I divide them?
I don't know, I told you that.
139.01312.
Vicky already probably told us that. And then the question becomes, so if I multiply together, I'm fine writing that out, but now I have to put it in the correct sig figs. How many sig figs do I have? Why 2?
That's because they're all defined exact values.
They are not.
Not?
No, I told you this last week, but it takes another.
Because 73 is more than the actual listed information in the problem.
No, not enough. 73 does have 2 sig figs. You're right about that. We said anything that's within, yep, Sean?
Well, because the centimeter to inch is not exact,
Yeah.
so they both have 3 sig figs. but
That's a
the
measured
least one,
thing.
which is 73.
It's measured because inches and centimeters are in different units. They weren't defined together. So we measured out, okay, if this is exactly if this is 1.00 inches, how many centimeters go in there? It's still 3, it's more than this. But it is defined. And then this is exact because we defined there to be exactly 2 inches or 12 inches in 1 foot. So here we would have to pay attention to that, but it doesn't affect us in this one. So we get 2.4 feet with sig figs. No, it's just when we're going between different unit bases. We can go all in the metric system, and that's all defined, or all in the English system or imperial system, and that's all defined. But once we cross, then we get.
So you still only use 2?
Still only
Even though
2,
there's 3 in there.
because the 73, we use the smallest number of sig figs, which was 2. So that's where you get into now, okay, if I've got 2 here, 3 here, infinite here, smallest number is 2, so that's what my answer is. We're going to have like half the hour here to practice, but I want to do one more. And that is, let's convert 55.0 miles per hour into meters per second. Meters per second is the most common set of units that we'll use to measure speed in physics. So it's sometimes instructive. Well, but we don't have a good feel for what a meter per second is. So sometimes it's really instructive to convert from miles or back into miles per hour. And I'll give you a couple pieces of information here, namely that 1 mile, 1.000 miles, is equal to 1.602 kilometers. And that should be enough for us. We should know the rest. But this one's a little weird, or at least there are 2 ways that you can set it up. One is a lot easier, I find, than the other. We are starting with a fraction already. We're starting with 55.0 miles per hour. This per means that it's over 1 hour. Let's write it that way. So instead of saying 55.0 miles per hour on top, I'm actually going to, and then put that all over 1. It's equivalent to saying that that's over 1.00 hours. And I can treat each of those a little bit separately. It makes the problem a lot easier or a lot more manageable anyway. I know that, let's start on the top. We'll convert both of those individually, but let's start on the top. I want to go from miles into meters. I'm going to have to go through kilometers to do that. But I know miles needs to go on the bottom. I don't know how many miles per meter, so let's get it into kilometers because I know I'll be able to work that out. So it's 1.602 kilometers is equal to 1 mile. Then miles cancel out. Is it 609?
Yeah.
8? 9? Okay.
Oh, 9.
9. Thank you. Then from kilometers, I want to go into meters. So I know I got to get rid of kilometers, but I also know that 1 kilometer is equal to 1,000 meters, and that's a defined one. So now I'm in the right distance units, but I'm not to the right time units. I want to get rid of hours. How do I set up a fraction that gets rid of hours? 1 over 60? 1 hour over 60 minutes would work. And the hour goes on top, exactly right, because then I can cross top and bottom out. So 1 hour, 60 minutes. Hours cancels with hours. Now I have to do the same thing to go from minutes to seconds. Minutes has to go opposite on top. And I know 1 minute is equal to 60 seconds.
So then to make that one easier, would you just be able to do 1 over 360?
Yes, it would also be wrong.
Be wrong.
And I'm glad you brought that up because I was debating in my mind, should I ask them what 60 times 60 is? It's 3,600. If you can remember 3,600, absolutely. If you feel like, oh crap, I'm going to put 360 down, do it this way. So multiplying across the top, we'd have 55.0. That is a super easy and common mistake, which is why I thought of it too. That bring up times 1,000 meters on top, and then on the bottom we have 1 times 1 times 1 times 60 times 60, and the units are seconds on the bottom. When you're entering these into calculators, you may practice safe math. That would be fine. There are 2 ways to do that. Actually, you should. But there are 2 ways to do that. So I'd enter all of these across the top, 55 times 1.609 times 1,000. And then you can divide, and if you put 3,600, that's okay. Or you could put in parentheses 60 times 60. Or you could say divided by 60, divided by 60, and that will be okay too. And I get 24.58 meters per second are the units, meters over seconds. How many sig figs do I have? So 3 in this step. How many in this step? I heard somebody whisper 4. How many in this step? Infinite. Because that's in the same unit. How many in this step? 60 minutes is defined to be exactly an hour. Same with the last one. So these 2 are the only 2 that are limiting us. Obviously the 3 is a smaller number. So we'll do that. 2 things whenever you answer stuff that aren't going to ruin you in a test situation, but will get dinged every single time. Significant digits, units. Make sure you've got both of them. Don't leave your numbers naked, or I hesitate to say, or dangling out there. What we've got almost half the class period now, on that note, to work on the next homework.